Good day, everyone. My name is Mr. Shegun and I'm a mathematics tutor. So today we'll be looking at a topic which is linear inequalities. Linear inequalities. So I know that most of us are familiar with this topic. We have probably in some time learned about this, but I'm going to shed more light and give us a better understanding of what linear inequalities is all about. So we're going to take some practice questions, especially from WAEC, right? We're going to take some WAEC class questions and see how to tackle questions involving linear inequalities, and then we're going to go into two variables and so on and so forth. So quickly, let's dive into the topic. Now, before we take the first example, now what I want us to know is that linear inequalities, as the name implies, right? When you say linear, linear simply means a straight line. It was actually gotten from the word line. So linear means that's a straight line. Now, in other words, or you want to put this in a better way, right? We have different kinds of equations, alright, or expressions. We have linear expressions, we have quadratic expressions, and so on and so forth. Now, for the fact that this says linear, that means the highest power of the unknown is 1. If it was a quadratic inequality, we have quadratic inequalities also. Now, if it was a quadratic inequality, the highest power there will be 2. So since this is a linear inequality, the highest power here will be what? 1. So in some other videos, I'm going to teach us how to solve quadratic inequalities, how you can represent them on number lines and so on and so forth. So let's quickly dive straight down into this. Now, inequalities, when studying inequalities, we have different signs, right? We have the greater than, we have the less than, greater than or equal to, less than or equal. Let me just put some of them down so you can actually see for yourself. So we have this is greater than, this is less than, lesser than, this is greater than or equal to. I'm sure most of us are familiar with all this. This is less than or equal to. This is not equal to. This is not greater than or equal to. This is not lesser than or equal to. So these are basically most of the popular signs we use in linear inequalities. So let's take an example and see how we can solve some problems. So like I said, we're going to take some WAEC past questions, right? So let's take this past question and see how we can go ahead and solve it. So it says, solve So the question says, solve the inequality minus 2 into brackets 13 plus x is greater than, remember the sign, right? This is greater than or equal to 9 plus 5x. It says represents the solution on a number line. Now, this is telling us to do two things actually. First, we have to solve this inequality, of which we are going to do now, and then later on, once we're done with that, the solution, we're going to represent the solution on a number line. So let's go straight into that. So we have minus 2 13 plus x is greater than 9 plus 5x. Alright, so very quickly. Now, this is a linear inequality. Alright, or you can say this is a linear expression. Why do I say that? Remember, for it to be linear, the highest power of the unknown must be 1. So the highest power of the unknown here, which is x, is 1. So that's what makes it a linear expression. Now, whenever you have something like this, the first thing you would want to do is try as much as possible to simplify them. Then once you're done with the simplification, go ahead and collect like terms and then get the value of x. So the first thing I'm going to do here is to simplify, like I just said. So the first step we're going to do here is to simplify this, and the first thing we'll do is we're going to open up this bracket. So minus 2 multiplies everything you have in here. So let's go. Minus 2 times 13, that's minus 26. Minus 2 times plus x, that's minus 2x. And then you have your inequality sign greater than or equal to what? 9 plus 5x. Alright? So the next thing you're going to do here is to collect like terms. So those that have the variable x, you put them on one side. Those that don't have, which are the constant term, you put them on the other side. So let's go. Minus 2x, you have it here, right? Now you have plus 5x. So if it crosses over, so please take note, whenever a sign crosses over an equality sign or an inequality sign, as it may be, right? Please, the sign always changes. So please take note of that. So not just for equality sign, it also applies to inequality sign also. So you take this to this side, so that becomes minus 5x, and then this is greater than or equal to, you have 9, and then this comes over to this side, you have minus 26, comes over and becomes plus 26. So you have minus 2x minus 5x, that gives us minus 7x. Is greater than or equal to, what's 9 plus 26? 9 plus 26 should give us 35. Gives us 35. Now we have minus 7x is greater than or equal to 35, right? Now, looking at this, the difference between inequalities and equation is that they are just, there's a slight difference actually, alright? I'm just going to list one. Now, aside the fact that you use the same principle and the same method to solve them, other like terms, simplify. Now, there's a slight difference, alright? Whenever the coefficient of x, or in this case, the coefficient of the unknown, so the unknown can be any letter, it can be A, B, C, wherever it may be. But in this case, the coefficient of x, whenever the coefficient of the unknown is negative, please take note the coefficient of the unknown. So in this case, the unknown here is x. So if the coefficient of the unknown is negative, please always make sure you reverse the sign. Always make sure you do what? Reverse the sign. So in this case, if it is greater than initially, you reverse it to less than. If it was less than, you reverse it to greater than. So that you get the point. So let's go. So divide both sides by the coefficient of x, which is minus 7. So you have that x. Now, since the coefficient of x here is negative, right? Remember what we said. What are we going to do? We're going to reverse the sign. So since we are having greater than or equal to, we're going to reverse this and change this to less than or equal to. Correct. You got it. So this is less than or equal to. So we have that. 35 divided by minus 7, that would give us minus 5. Correct. Minus 5. So we've given the solution to this. We have that x is less than or equal to minus 5. But remember, the question doesn't stop there. It says once we are done solving, right? It says something else. We should do what? Represent the solution on a where? Number line. So that is what we are getting into now. Now, to represent this information on a number line, it's not difficult actually. Now, a number line is actually a Cartesian graph, right? But the only thing, rather than having the y-axis and the x-axis, the only thing you take out from a Cartesian graph to construct or to get a number line is the x-axis, alright? So, if you have the x-axis like this, and you have your origin, this is basically a number line. So that's what it simply is. It's not difficult, nothing fancy, alright? So number line is basically a Cartesian graph or a Cartesian plane, but instead of having the y and the x-axis, you only extract or take out the x-axis. So and you have your origin. So we know that values by the left-hand side are negative. The values after the 0, that is on the right-hand side, are positive. So since this is minus 5, so Obviously, we're going to place the value here because the values from 0 down to this part are negative on your graph, right? If you have this, right, if this is the origin, the values here are positive, the values here are negative. For y, the values here are positive, the values here are negative. So the same thing applies to number line, alright? Nothing changes. Remember, it was gotten from the Cartesian graph, so it has to follow that same order. Okay, so let's go. So I'm going to place my -5. You can actually place it anywhere, right? Since this is just a sketch, alright? It's not actually you're plotting a, so it is a sketch, you can just put it here. -5. -5. But let's, for the sake of this course, let's take it closer to this -5, right? Now, very good. So represent this on a number line, alright? So this is what we'll do. Now, there are two ways you can actually do this. I'm going to show you the first one and the second one. Right? Whichever one you choose is still very much okay. So I can decide to, I would put down, just draw a line on -5, a short line, alright? A short vertical line on -5. Stick with me. And then I'm going to put a circle on top, right? More or less like you have all this lollipop sweet now, right? So just put a circle and then so like this. So that's the same thing I have over there. Alright? Now, to do this, just look at the direction of the inequality sign. So the arrow, look at this. Now, the inequality sign looks like an arrow, right? And the arrow is pointing in what direction? In this direction, right? So it is simply telling you that if x is a value that is less than or equal to -5. Now, the values that are less than or equal to -5 starts from -5. Why did I say -5? Because you have equal to here. So equal to simply tells you that -5 is included. So please take note of that. If I had just x is less than 5, I wouldn't say the values that are less than 5 starts from 5. No, because 5 is not less than 5. 5 is equal to 5. Did you get the point now? So the values that are less than 5 starts from 4 and move downwards. Alright, so let's quickly move on. So we have taking this direction. So we're going to draw the arrow of the line in this direction, right? Because we're going this way. Now, I'm not going to stop here. I'm going to shade this, right? And why am I shading that? That tells you that -5 is included. Because if you have greater than or equal, this equal to here, this equality sign here, is the reason why we are shading this part. So, and that is how you represent on a number line. If you don't want to do it this way, you can do it this way. Alright? So you have you can also do it this way. This is still acceptable. Alright? So that's that about that. So this is still question under, we call this inequality in one variable. Inequality in one variable. Why do we say inequality in one variable? Because we have just one unknown. So the only unknown here we have is what? Is x. So very quickly, I'll be diving into two unknowns, showing us how to represent that on the Cartesian graph. Now, the reason we'll be representing that one on the Cartesian graph is because now this one is one variable. Now, you can represent one variable on a number line because a number line consists of just one variable, which is x. Are you with me now? But when we are looking at two variables, that means we're going to look at two unknowns, which is x and y. So we are going to have a complete graph. Alright, so let's quickly go into linear inequalities in two variables. So we have a question here. We have moved on to linear inequalities in two variables. Remember what did I say about two variables? Instead of working with just one variable. In that case, remember previously we worked with just one variable, which was x, and we had to represent it on a number line. Now that we are working with two variables, we'll have to represent it on a Cartesian plane or a Cartesian graph. So let's go. Now, show on the graph the region that contains the set of points for which for which 2x plus y is less than 3. So these are questions you will likely see, alright? So they are giving you a question here, an inequality. It says 2x plus y, right, is less than 3. What they are telling you now is represent this information on a graph. You can see that now. In the previous one, we represented it on a number line. So a graph in this case indicates that you have to use both the y and the x. Remember, right? Because we are dealing with the two variables. So how do we do this? Now, what I like to do is, before you can represent this on a graph, what I like to do is I like to find their intercepts. So we have to look for x-intercept and y-intercept. I will tell us what that means, right? Just stick with me. So I would say start with x-intercept. Now, what does x-intercept mean? X-intercept simply is the value of x as y approaches 0 or as y equal to 0. That is what x-intercept is. So this simply means what is the value of x when what? Y is equal to what? 0. So don't allow this one to confuse you. That is what x-intercept means. So x-intercept, what's the value of x when y equals 0? Then y-intercept will be what? What is the value of y when x is now 0? Beautiful. So let's go. Now, in this inequality, what I'm going to do here is I am going to put y to be equal to 0 so I can get the x-intercept. So let's do that. 2x plus, in place of y, right? Since we know that y is 0 because we are looking for the x-intercept, remember. So I'm going to change this to 0. Now, for temporarily, right? We're going to change this inequality sign to equality sign just for a moment, right? I'm still going to turn it back. So I'll tell you why we are doing that. So let's change it to equal to 3. So we have 2x is equal to what? 3. So divide both sides by 2. We have that x is equal to 3 over 2. Or if you want to use this in mixed fraction, you have 1 over 1 whole number 1 over 2. So that is the x-intercept. So this is how we represent it. We will say when x was 3 over 2, comma, y was 0. Now the reason we do it like this is because if you have something like this, x comma y, this here is a point. Time will not really permit me to go deep into algebra, right? But just take note that please, x always comes before y. Whenever you are identifying a point on a graph, x comes before y. So take note of that. So that's why I put the value of x first, which is 3 over 2, and then y was what? 0. So now let's go into the y-intercept now. I'm going to divide both and do that here. So say y. So for y-intercepts, remember who can tell what will be equal to 0 now? X, exactly. X will be equal to 0. So you see when x is 0. So using the same inequality, right? So let's go. I have 2. So rather than putting x now, since we know that x is what? 0, I'll now put in brackets 0 plus y. Remember, let's change this to equality. That's 3. So you have 2 times 0, that's basically 0, plus y is equal to 3. So that means obviously y is equal to 3. So that means y-intercept, the value of y there was 3. So if I were to represent this also, just like I did this, right? Now, remember what did I say comes first? X, right? So am I going to put 3 or I'm going to put 0? I'll put 0. So I'll say 0, comma, then 3. So that means when x was 0, y was 3. When x was 3 over 2, y was 0. So this is what we call intercept. So the reason I'm doing all of this is because the question says we should represent this inequality on a graph. So please, students and those passionate about learning mathematics and all, please always make sure you do this. Find x-intercept, find y-intercept. Once you've gotten that, then you can represent it on a graph. So let's go straight down into that. we've gotten our intercepts, x-intercept and y-intercept. So I remember I said I wanted to tell us why I changed this. So the reason for that is just for clarification purpose. And why do I say that? Now, it's just to not really much, just to actually know that x was 3/2 when y was 0. So that's just the basic reason for changing that. So obviously we're still going to change it back to its the way it was before. This is what we're working with. We are just using this equality sign based off of the fact that we want to find x-intercept. We're still going to change it back when we are representing them on the graph. So let's go. Now, since you can either do this in two ways. You can do a sketch of the graph on your notebook, or you can get a graph book yourself, alright? And then, but since we are doing this, since this is an online class, right? We're going to represent this on a board so you can actually get the idea of it. So let's have our y-axis and our x-axis. So this is basically how a Cartesian plane looks like, or a Cartesian graph, or a graph, right? Now, we have 2x plus y is less than 3. The goal here is to represent these guys on that graph. So let's do that quickly. Now we're going to start with the first coordinate, on the first point. We have 3/2 and 0. Let's start with that. So this simply means when x was 3/2, y was 0. Beautiful. When x was 0, y was 3. Remember I told you x comes before y. Please do not forget. So let's start with this. Now, for the first one, which is 3/2 and 0, x was 3/2. Now, meaning x was positive here. Are you with me? So since x is positive, the positive values of x always lie in this region. You agree with me? And the negative values of x lie in this other region. Positive values of y, this region, negative, and so on. So since x is positive here, which is 3, that means 3/2 will be within this region, right? Beautiful. Now, 3/2 basically is 1.5. It's in between 1 and 2. 1 and 2. So to get that idea, I might just put 1, right? Let's say we are using 1 unit, for instance. 1 unit simply means the common difference is 1. You're going 1, 2, 3, 4, 5, 6. 2 units, you are using 2. The common difference is 2, 2, 4, 6, 8, 10, and so on and so forth. 3 units, 3, 6, 9, and you get the point. So now, let me make this a bit spacious so we can. Okay, now, so if I want to identify x is equal to 3/2, which is 1.5, alright, in between 1 and 2. So I'm going to have it somewhere around here. So let's say this is where 3/2 is located. Alright, so now let's mark that point with an asterisk. Alright, the next point is when y was 0. So obviously 0 is the origin, you do have to. Now, let's move on to the next coordinate, or the next intercept, which was y. So when x was 0, now y was what in this case? Y was 3. Are we seeing this now? It's very simple, not difficult at all. Once you follow this pattern rather, it's very simple to do. Y was what? 3. So let's identify. Now y is positive here. Is that correct? So that means y is equal to 3 should be around this region, not this region. Why? Because y is not minus 3. Y is positive 3. So I'm going to locate 3 here. 1, 2, 3. So remember, this is a sketch, so it's not. So let's locate, mark this point with our. So you draw an asterisk there. Can we see that now? So very simple. Now we are not done. Now this is the point where we have to go back to the inequality now. Now listen. The inequality used, or the inequality sign used here, is less than. Now listen to this. If you have less than, greater than, make sure you use a broken line. A broken line. If you have less than, equal to, greater than, equal to, use a solid line. Alright, I'll tell you why that is, but just stick with me. So since we have less than and greater than, alright, if there is no equal, if there is no equal to, use a broken line. Broken line simply means something like this, right? Solid line, just straight. Okay, good. So let's use that concept here. All right, let's go. Now I'm going to connect these 2 points with a straight line. All right. Now let me ask you: this straight line, is it going to be broken or solid? Now looking at the inequality sign you used here, this is less than. And remember I told you, if it is less than, what do you use? Broken line. So let's connect the points using a broken line. Let me wipe this off. Put it down somewhere here. Broken line. Solid line. Now, I said I'll tell us the reason. The reason why we do that is because we use broken line. And the broken line tells us that these values are not included. Remember, if it is less than, these values are not included. So meaning you can't count 3 and you can't count 3 over 2. But if it was less than or equal to, we would have used a solid line, meaning there will not be breaks, alright? So that tells you that the values 3 and the values 3 over 2 are included. So that is why we do that. So now, we are not done. Just one more step and then we are done with this question. Now, it says show on the graph the region. So we have to show on this graph, we have to tell them the region that satisfies this inequality. So what region satisfies this inequality? In this graph now, so we have different regions here. We have this region, we have this region, but what particular region satisfies this inequality? Now this is how you do it. Very simple. Whenever you want to look for the region, what we do is that we shade the region that is wanted. Now this is it. Let's say for instance, this is the region that satisfies it. For instance now, right? This is the region that satisfies the inequality. I'm going to shade it. Alright? Shading it tells me that okay, or tells whoever that is going to mark it, tells the person that okay, this is the region that satisfies it. Alright? Now the part you don't shade simply is the unwanted region. Now you can actually mix it up, alright, and do the reverse. You can shade the unwanted region while you leave the wanted region unshaded. I believe you understand what I'm saying now, right? So, but in this case, what we are going to do is we're going to shade the wanted region, meaning the part we want. So let's quickly do that. Now, we're going to look at the value of y. The value of y here is what? Is 3. And the sign you use here is what? Less than. So I'm going to say what? So please, whenever you want to shade or look for the region, always focus on the y value. Please do not forget. So I'm going to look on y now. The value of higher here is what? 3. What are the values that are less than 3? The values that are less than 3, are they below 3 or they are above 3? That's the question you ask yourself. So please always make sure you do this. Whenever you want to look for the region you want to shade or the region that satisfies the inequality, please go to your y. It doesn't concern your x-axis now, alright? Now it's your y-axis you're looking at when it comes to the region that satisfies which. So now, since this is less than, the values that are less than 3, are they above 3, right? Or they are below 3? The values that are less than 3, obviously, are below what? 3. So I am not going to shade this part. Why? Because this is not the part I'm looking for. The values that are below, remember, right? So the values that are below, I'm going to shade down. Why? Because these values here are below 3. So you are not really focused on the on x. Yes. So let's do that. So this shaded region or this shaded portion indicates or tells us that this is the wanted region. So I'm going to write here 2x plus y is less than 3. So this is, I'll call this the wanted region. So it tells us that this is the area or the region that satisfies this inequality. So that will be all for this question. So we are basically given the solution, we solved it, and then we represented it on a graph. So that will be all for this topic. Although we have more, we will have some questions where you'll be given about 2 or 3 inequalities, and then you have to represent it on just one graph. So imagine you have like about 3 of this, right? And then you have to represent on. So we have questions like that also. So we're putting it to a stop here today. So thanks for watching. See you in the next class.